Recording.
Here we go. Great. Good morning, everyone. Thank you so much for joining us today. I'm Naomi and I work with 3C Ren out of the County of Santa Barbara. And before I pass things off to Russ for our course today, I have some quick logistical slides to go over. You go to the next slide, please. Just a few Zoom reminders before we get started. Please make sure you're on mute for the duration of the course, and we encourage questions. So if you have any questions at any time, please use the chat and we can answer them. As you just heard, this session is being recorded and the slides and recording will be shared with you within the next few days. And as a reminder, this training is eligible for both AIA and ICC learning units. And we're distributing learning units based on Zoom attendance. So if you want to receive learning units for today's, please make sure you're joining us at the link that we sent you after registering. And if you have any questions, please reach out to me and I'll pop my email into the chat soon. By this point, I'm sure most of you are very familiar with Zoom, but we ask everyone if they are mute again. And I think that is it. So if you can go to the next slide, please. Just a few words about Tri-County Regional Energy Network, or 3C REN. 3C REN is funded by ratepayer dollars that we all pay into our utility bills through the public goods charge. And the benefit of this being ratepayer funded is that there's no cost to those that we serve. And as a regional energy network, we can return these dollars back to our local economy, which has historically missed out on some of these funds. Next slide. We currently offer 6 programs which are focused around 3 services: incentives, training, and technical support. This training today is part of the Energy Code Connect program, and you can see additional trainings being offered and learn more about other services by visiting our website, 3cren.org. HES, or Home Energy Savings, offers incentives for single-family homes and multifamily homes. And we also have BPT and Energy Code Connect, which will provide trainings for those in technical assistant in the energy code and those in the field. And we also now have technical assistance for agriculture as well. Next slide, please. Just to highlight some of our achievements, since 2019, we've had over 4,000 individuals attend trainings, answered 334 Title 24 and Cal Green questions, secured $155 million for investment in the region, and completed 1,374 energy saving products. And we're really excited to continue growing in all these areas in 2025. And with that, I will pass things over to Russ to start today's training.
Awesome. Thanks, Naomi. Good morning, everyone. Glad you could be here. It's very nice to be here myself to bring this information to you. We appreciate you taking some time out of your day. And this particular class has actually been around for a while. I think it was originally written for a KBEC conference quite a while ago, but it's an important class, and it sort of it was intended to sort of grease the skids between energy consultants and HERS raters and the installers in the field who have to install the stuff and get their stuff inspected. It's when some of the HERS tests first came out, energy consultants weren't quite sure what it entailed and didn't think too much about it. And I like to use the analogy of you're at the top of a very snowy mountain and you start a little snowball and you roll it down the hill and the snowball just gets bigger and bigger, bigger, bigger. And if it goes uncontrolled, by the time it hits the bottom, it's going to take out the little town at the bottom of the hill. And so that's kind of what it's like when an energy consultant starts checking these boxes in the software and saying, yeah, let's do this HERS test. Oh, let's do this. Oh, look how much credit I get. Let's do this HERS test. But you don't think about what you started in motion. And if you're not careful, it can cause a lot of issues out on the job site. Okay. And so this class is sort of geared towards energy consultants, which are the folks running the software, the performance software like CVEC Res or Energy Pro, and running the software and making the building comply with the energy code. And they are sort of the first person who makes decisions about what has to go into this house. And of course, you want to get those decisions approved by the architect and approved by the builder and things like that. And so there's the energy code over the last few code cycles has gotten more and more complex and requires more and more logistics. I actually started doing energy compliance calculations back in right out of college in 1988. on a computer. It didn't even have a hard drive. I mean, we were swapping floppy disks back and forth. And back then, you would get a set of plans and you get it in the computer, you tweak it a little bit and get it to comply, and then say, okay, here's what you have to build. And it was basically a pass through. You were just you got the stuff, you hand it off, and then you never heard from it again, unless they really screwed up in the field and didn't install what it said on the reports. But nowadays, I mean, the first CF1RU print is very, very unlikely to be the final CF1R that the house gets, because there's so many changes happen, so many tweaks. So you really need to have your finger on the pulse of a project. It's a lot more involved now, and I hope everyone's charging accordingly. What we really don't want, and by the way, I'm on the board of directors of CABEC, the California Association of Building Energy Consultants, and we have a voluntary certification program for CEA and all that good stuff. And there's a tomorrow, I believe there's a professional practices workshop they're putting on to sort of explain to energy consultants how they should behave, how they should do their job. And a lot of that hinges on communication and coordination with your clients. Okay, whether it's an architect, whether it's a builder, whether it's a general contractor or whoever. Just you can no longer work in a vacuum, and run the compliance, get the house to comply, and then throw your energy report over the wall and forget about it. Right? It's you're there almost till the very, very end, until that house gets finalized. You need to be on call. You need to be accessible. You need to be having people talk to each other that need to talk to each other. So it's a much more involved job than it used to be, and that's kind of what this class is all about. So hope you get something out of it. So just some facts. It's definitely hard. Every code cycle, it gets harder to get a building to comply, right? And so it's definitely much harder to get a building to comply under the current code than it was under the previous code. And it's going to be harder to get it comply in the next code, the 2025 code, which takes effect on January 1st of next year. And by the way, we're already working on the 2028 code. So they're way out ahead. The codes are way out ahead of the code cycles, and we can tell you for a fact that each code cycle it gets harder to make a building comply. Okay, for the most part. It depends on your climate zone and the types of buildings and stuff like that, but that's generally true. And so if it's harder to make a building comply, you have to start looking for more options of features to get energy credits. Okay, and by an energy credit, I mean it's a feature that when you put it on the house in the compliance software, it reduces the energy use of that house and improves the compliance margin, if you will. All right, so that's what I consider an energy credit, is a feature that reduces the energy use of the proposed house in the compliance software. And so when you start looking for these other new things to put in the house, you're going to start saying, oh, well, here's a feature I've never tried before. And let's say, oh, look at there. It makes the house comply. Oh, that's great. And then you put it in there and you send it off. But what you don't realize is maybe by simply checking that box, you've caused the builder to do something to the house that might be impractical or infeasible or just plain impossible. And so it's very important that you know exactly what happens when you check a box. Okay, so I apologize if you hear my dog barking in the background. I think there's somebody at the door. Some of these first measures can no longer be modeled away if they fail out in the field. And what that means is if you put something in there and they go out, they build a house, the HERS rater comes out and tests it and it fails. Well, there's two options. One option is to fix that thing, make it pass the test, okay? But sometimes you simply can't do that. I remember when QII first came out, the quality installation credit, when it first came out, I was constantly getting calls from HERS raters saying, hey man, I went out to this house to do a QII inspection and they sheetrocked over the insulation. What do I do? And the answer is you fail it. You have no choice but to fail it. If you can't see that insulation, you can't pass it. So it's a fail. And so then what's their choice? Well, their choice is to either rip off all the sheetrock and have you inspect the insulation, which they're not going to do, right? And so the other option was then they go back to the energy consultant and say, hey, we screwed up. We can't do QII. You need to rerun our house in the compliance software, without QII and make it pass, okay? And back before QII was a prescriptive credit, it was like an extra credit, and it wasn't that difficult. It's a big credit, and so if you take it off the house, you've got to put some other credits in the house to make it pass. And back then, you know, it wasn't that difficult. You could look at things like adding more ceiling insulation. Remember, you're pretty far along in the construction of the house. You've already sheetrocked the house, so you can't replace windows, you know, stuff like that. But you could go and look at the actual windows that were installed and say, are they better than what I modeled? And then, you know, plug that into the software and stuff like that. But there's things you can still do to a house when it's that far along. You can add ceiling insulation. You could replace the condenser or install a condenser if it hasn't been set yet, with a more efficient condenser, maybe a more efficient, you know, heat pump or furnace or whatever. So there are some things to do. But nowadays, under the current code, that is really, really difficult. And if you don't pass QII, it's going to be really tough to make that house comply. You got to start looking at things like batteries and improved solar panels and all kinds of crazy stuff. So anyways, that's what the point of that bullet is so, which makes it all that much more important that those HERS measures pass, okay? And that makes it that much more important that the energy consultant lets everybody know, hey, I put this HERS test in this house. Please coordinate with the builder. Please coordinate with the architect. You know, there may be changes that have to be made to the plans, you know, stuff like that, okay? And so that's what we're going to talk about. From the energy consultant's perspective, modeling HERS measures is about as easy as it gets. I mean, literally, something it's just like literally, it's just like checking a box, and that will put that HERS measure in that house. But the people after that have a lot of work to do. Okay, so a responsible professional energy consultants need to make sure that the features they model can actually be installed in the house. Okay, and so first of all, you need to know what the HERS measures are. You have to know what do they entail as far as being installed in the house, and then you have to know what it entails in terms of testing them. Okay, sometimes that's the hard part. You can install something that meets the requirements, you know, other than the testing, but it can't be tested because of the way it was installed. And a good example of that would be like indoor air quality fans. You know, the way those are tested is they put a little flow hood over the fan. If it's a supply fan coming into the house, they just you know, put the hood over the thing. Or if it's an exhaust fan, they just put the hood over the thing. That's fine. But what if it's a indoor air quality system that is attached to the return side of the grill? Where is that outlet? Where is that intake on the outside of the house that's bringing that fan? And if that's, you know, 25 feet up in the air underneath an eave, the HERS rater is probably not going to be able to test that. It's going to be very, very difficult to test. So the ability to test these HERS tests is a very important consideration as well. And so what that last bullet says is this includes being able to pass any test. All right. So don't check the box without knowing what the implications are. Energy consultants need to communicate the potential costs, the requirements of each HERS measure, as well as the inspection requirements, okay? When you specify a HERS measure, I highly, highly, highly recommend that you do the research first before you specify this measure. But in order to communicate those requirements, that you go to the reference appendices, all right, and you tell them, here's what the protocols are for those tests. Here's what it's going to take to pass those tests. And the reference appendices, of course, is that gigantic document. And let me, actually, I've got it open and I'm going to pull it over. Oops, not that one. Where is my Adobe? There it is. So you should be familiar with this document here. This is the reference appendices. Amy, can you see that okay? Okay.
Yes, that's great.
Okay, so this is that huge document, the 2022 residential reference appendices, and down here it's 591 pages in this document. But this is section RA2-4, and this is table RA2-1. This is a list of all the HERS measures, okay? And then it has a brief description of the HERS measure, but then look over here. This section is what we call the HERS protocols. This is the step-by-step instructions for what the HERS rater has to do in order to pass this test, okay? And this is really super important because this is what the HERS rater has to follow, all right, when they're out in the field. So this, from the installer's perspective, this is like the answers to the test, right? This is like, here, this is what the HERS rater is going to inspect. Install your features so that it passes this test. Okay. So making this information available to everybody who's downstream from you will really prevent that issue from coming back and biting you later on. All right. And so you see all the tests here. Here's duct sealing. That's one. Duct location, surface area, and R value. That's actually a series of tests. Verification of low leakage ducts located entirely in conditioned space. All right. Even if ducts are inside conditioned space, they still have to be tested for leakage. Low leakage air handling units. All right. That's a special credit. Verification of return duct design. There's this weird table. I'm honestly not a huge fan of this. But in order to avoid the airflow test and the fan watt draw test, if they install their return ducts that meet these tables, I'll go into more detail on this later. But if they install the return ducts to meet these tables, they don't have to do those tests. And so it's kind of popular, but it requires that you have the room to install these ducts. Basically, what it says is if you put giant return ducts and return grills on your system, we're pretty confident you're going to have good airflow. I personally don't think, I think that's a big assumption, because you can definitely have big return ducts and still have way undersized supply ducts and not meet it. But it's one of those things that the Energy Commission sort of, it was a concession that the Energy Commission gave to the big production home builders who were concerned about, failing tests after these houses were built. So they needed an option to sort of preemptively pass these tests. And this is what they came up with. Not a huge fan of it, but it's there. Verification of air filter device design. Sometimes that gets triggered. Verification of prescriptive bypass duct requirements. Sometimes that's an interesting one that gets triggered. If you're doing any kind of zonal control, the HERS rater has to go out. If they modeled it with a bypass duct, the HERS rater has to test it. Or if they model without a bypass duct, the HERS rater has to make sure that there's not one on there. Improve refrigerant charge. This is a big one. This one is very susceptible to weather. So if it's cold outside, you may not be able to do this test. Oh, and by the way, as you guys know, the energy code is really encouraging heat pumps, and heat pumps require refrigerant charge verification, no matter what climate zone you're in. Okay, and so that can trigger HERS verification, but it is a prescriptive measure, so you can model it away if you need to. And then heat pumps, especially the mini splits, are very difficult to do a refrigerant charge test. So you have to do the weigh-in test, which requires some special coordination and things like that. Okay. So I just noticed a question here. Why are there so many free classes about energy efficiency, but the only HERS certification options are over $2,000? Well, that's because of who's giving that training. The energy training is funded by ratepayer fees and things like that. So 3C REN, they give free training. The utilities, they give free training, stuff like that. But the HERS certification training comes from a private for-profit entity, Cheers at this point. It used to be CalSTRS. We'll talk about that, but they're private companies and they have to make money. They're not funded by the government in any way. And so in order for them to make money, they have to charge you for that. However, I do know for a fact that there are some subsidies. I know down in SoCal gas territory, there are some things. So check with Cheers and see if there's any programs out there. I want to say it's been a while, but there was a community college that had some funds to provide certification training. So shop around. You should be able to find something. Okay. Let's see. I won't check these other comments in the, I'm looking to learn all things HERS. Good for you. Awesome. We'll see what we can cover. Hi, Zach. Yeah, just talk about that. Oh, interesting question. And so Zach is asking, if your Title 24 report triggers some HERS measures, but the owner of the building wants some extra tests to be done, what should you do? And he's asking, is there a way to modify the Title 24 compliance so that it triggers these? Actually, I would recommend that you separate required HERS tests from optional HERS tests. To obviously talk to the HERS rater. The HERS rater is the one, and they'll charge you extra for the optional ones. But the reason I would suggest that you keep those separate is because once they get triggered, there's all this paperwork and stuff has to happen, and you don't want an optional HERS test to hold up a project, right? Um, so so keep the ones that are required by Title 24, keep those in the registry, have all the other ones like in a separate, scope of work for the HERS rater. And then the HERS rater can fill out a form that looks very much like a compliance form, has the same information on it, but it's not something that, the building department is going to require, and it's not something that could potentially hold up a project in the event that an optional test fails, right? You don't want to have to prevent homeowners from moving into a house just because they wanted this extra HERS test. So that's how I would suggest doing it. There used to be you could actually, I know in the CalCerts registry, you used to be able to check a box that said this is an optional test, and it would allow you to fill out the forms, but it wouldn't put the forms in with the all the other stuff. Okay. Um, let's see. George is asking, is all this complexity necessary? George, I ask that question every day. What are the highest leverage approaches to incorporate optimal energy efficiency and indoor air quality and thermal comfort in affordable housing? Well, that is a really deep question, and unfortunately, kind of outside the scope of this class. But I would encourage you to contact the folks at Quebec, and we have committees that discuss this kind of stuff. But yeah, and it's all, in Title 24, it's all about getting the house to comply in the software. And there's a thousand different ways to do that. You could hand the same exact set of plans to 5 different energy consultants, and they can all get it to comply in very different ways. And some ways are more cost effective than others. Okay. So a good energy consultant is very aware of the costs of the measures that they're putting into a house. Okay. Question from Martin. As of January 1st, what are the allowed heating and cooling load calculation? Oh, all right. Don't get me going on that one. That was a little outside the scope of this class, but it's a topic near and dear to my heart. Load calculations. Basically, it's manual JS&D. There's several software programs out there. The requirement to do load calcs, duct design, and equipment selection, manual JS&D on a house has been in the code since at least 2008, maybe even before that. The problem is that it has not been well enforced by building departments. And if you start seeing building departments enforcing it more and more, asking for load counts for new houses, even alterations and additions and stuff, it's because they're finally learning what that entails. I've taught a class for 3C Ren. I have a class for Bay Ren, and I think I've also taught it for IREN. It's basically a class for building departments, teaching them how to enforce manual JS&D, how to plan check it, how to check it in the field. And so more and more building departments are becoming more knowledgeable of that, and that's spreading around. And then other building departments have just realized that it's in the code and are enforcing it, but it's growing. Okay. But your question is, what are the allowed heating and cooling load calculation methods? The code says ASHRAE, which is really going back to the basic math. It mentions SMACNA, which shouldn't be in there, honestly. If you read, it's the SMACNA duct installation standards. If you read those, it refers to Manual J. So I don't know why the SMACNA is even mentioned, honestly. But the most likely one that probably 99% of all people will use is ACCA, Air Conditioning Contractors of America, or ACCA. Manual J, load calculations, Manual S, equipment selection, Manual D, duct design. There are 3 software programs out there that do all 3. There's a ton of software programs out there that only do load calculations. Okay. So you can go to the ACCA website, acca.org, and search for approved programs, and you'll see the programs there. Okay. Keep an eye open on 3C Ren, Bay Ren, IREN. I teach classes on how to do load calculations as well. And you can certainly contact me directly if you're interested in that. Okay, great question. All right, so see, Naomi, I told you I get sucked down these rabbit holes. So we should have plenty of time for me to cover all the slides, but just in case. So all right, improved refrigerant charge, installation fault indicator display, verified system. Okay, there's an entire list here that feel free, and I encourage you to make a copy of this table. Again, it's table RA2-1, RA2-1, summary measures for field verification and diagnostic testing. And again, so if you trigger a HERS test and you just go right to the CF1R and there's that summary of HERS measures, and then just go down that list, find those tests on here, highlight it, maybe give this to your client, but also find this section here, RA 3.1.4/3.8, and this goes through the step-by-step instruction. So this is really putting everybody on notice exactly what this HERS test entails. Okay. All right. Let me get this out of the way. Back to our slides. So table RA2-1. By the way, you guys will get a copy of all these slides after the class. Also know the requirements on the applicable CF2Rs and CF3Rs. Okay. So I like to say the energy compliance process is a 3-step process. Okay. The first step is figuring out what you're supposed to do to get the house to comply. That's the energy consultant's job, right? They work with the builder, they work with the architect, and then they get the house to comply. That's step 1. Step 2 is to install those features, build the house like you're supposed to. Step 3 is to have that house tested and inspected, either by the local building department inspections or the HERS rater, okay, to make sure those things are done correctly. In the commercial world, that's called commissioning, right? You build this building, is very complicated building, and you have people come out and make sure that building works like it's designed. That's the same thing for residential, okay? So 3 steps: figure out what you're supposed to do, install it, have somebody test it, okay? There are 3 kinds of forms in the energy code, and they are not coincidentally named the CF1R, CF2R, the CF3R. They follow each one of those steps, okay? The CF1R, step 1, figure out what you're supposed to do. The CF1R tells you what you're supposed to do in the house. The CF2R documents what was actually installed in the house. The CF3R documents the verification by the third-party verifier, okay? We don't have a form that comes from the building department. We just assume they go out there and check everything and everything's good, right? But we get a form from the third-party verifier, which is the HERS rater, okay? And by the way, I don't have this in my slide, so I may as well mention it now. They're trying to change the name. Well, they are going to change the name of HERS raters, in case you haven't heard. HERS raters are gonna be called Energy Code Compliance Raters, ECC raters, instead of HERS. They're gonna drop the name HERS, but there's gonna be a transition period where they're gonna say ECC raters, formerly called HERS raters, right? So just be aware of that. But anyways, the CF3R form is from the HERS rater. Okay, so there's 3 forms that tell you what you're supposed to do. The CF2R and the CF3R forms are very similar for those features. There's a bunch of CF2R forms for features that are not HERS measures. Okay, so there's more CF2Rs than there are CF3Rs. Only HERS measures CF2Rs get CF3Rs, right? So the CF2Rs, again, I like to call those, that's the answers on the test, okay? The installer is being tested. Someone's going to come out and test their work. And if they want to know how to pass those tests, the answers are right in front of them. The answers are on the CF2R that they're going to fill out. And then the CF3R gets filled out by the HERS rater, all right? So not only knowing what's in the protocols, okay, in table RA2-1 and all those sections, the actual forms themselves give you a lot of information. I encourage you, as an energy consultant, or even an architect or a building inspector, whoever you guys are on this class, is to just read those forms. They're all in the appendix of the. You can go on the Energy Commission's website and see what these forms look like and see what the questions are and read through them and go, oh man, I had no idea they had to do all this stuff just for this one teeny tiny little measure. Okay. So yeah, that's a great resource as well. All right, what else we got here? Question from Martin. As of January 1st, what are the allowed? Oh no, that's the same question. Sorry. I thought it was a new question. Nope, same question. Okay, so here's a list of all the HERS majors. That's a pretty impressive list. Honestly, I remember, gosh, it was 2000 and sorry, no, it was 19, it was 1997, 98, 96 that the very first HERS measure came into the energy code. All right, and it was duct leakage testing. And it was basically the Energy Commission was proposing energy features for a house that weren't easy to inspect. They were, in fact, they were quite difficult to inspect. They required some testing. They required special equipment and special knowledge. And so when they first proposed duct leakage testing as a measure, they just kind of assumed that it would be the building departments doing that test. And can you imagine a building inspector carrying around a duct blaster and doing duct leakage testing? It ain't gonna happen. All right. They have too many other things on their plates to do. And so I remember distinctly there was a representative from Calbo at this hearing, and the Calbo, I go, wait a second, you're thinking we're going to do these tests? And the Energy Commission said, well, why not? And they said, well, they're very involved, and we're not going to do it. So, anyways, they said, let's get a third party person to do these tests. So when this special test is required, the builder or homeowner has to go find one of these people who can do the test. There's plenty of precedence for that for special inspectors for other things, and we'll have them come do it. And so the person that they happened to pick to do these tests was called a HERS rater because there was this HERS program out there at that time, and HERS stands for Home Energy Rating System. So there was a program called the Home Energy Rating System where these people went out and tested houses and gave the house a score to quantify its energy efficiency that was used by rebate programs and utilities and stuff like that. So they knew how to use this equipment. And so that's why they got called HERS measures, is because that was the name of the person who was doing these tests. Okay. So just a little history behind that. But back then there was only I think it only started the first code cycle that had a HERS measures. It may have only been duct leakage testing. It may have also been blower door testing and duct leakage testing, but anyways, there's just very few. Now look at all the HERS tests, look at all the HERS tests, and some of these are pretty easy to do, and some of them are really complex. Some of them I honestly don't know. I have never personally seen a project that has some of these tests on them. Let me find one. What is it? Evaporatively cooled. Where is it? Oh, they're in the slides, I know, but there's HERS tests. Like, I honestly can't say I don't know any personal experience that this HERS test has ever been done or ever even been taken on a house. So some of them are pretty obscure. All right, but that's quite a bit, you know. And also, I train a lot of building departments, and you know, I show them a list kind of similar to this, and it almost invariably someone in the class will raise their hand and go, why don't HERS raters just do all of the inspections? Why don't you have HERS raters and take it off the plate of the building department? And doesn't sound like a bad idea to me, but you know, the Energy Commission is not real keen on HERS testing these days. But I think we're getting past that. I really do. So anyways, there's the list of HERS measures for 2022. For 2025, they're definitely not adding any HERS tests. The only things that are really changing is they're simplifying some of them and how they apply to low-rise multifamily, because you know the energy code is now separated in single family, low-rise multifamily, and then commercial. And so some of these are affected by that separation, and it's going to change a little bit in the 2025 code. Oops. All right, so let's talk about probably one of the most common and one of the most complicated HERS verification called QII. There's a lot of classes specifically on QII. If you go to Energy Code ACE, for example, I'm not sure if 3C Ren, do you guys have any classes specifically on QII these days? I know you have in the past. Um,
Not that I'm aware of, but I can take a look at the calendar and drop it in the chat if there is one.
okay, cool. Um, yeah, when QII came out, when it first came out, I want to say in the 2008 code, yeah, 2008 code. Um, it was by far the one HERS test that failed the most. It had the highest fail rate of any test because they just weren't used to it. They just weren't used to doing it correctly, and it just failed a lot. I think by now most builders and most installation contractors have at least been exposed to it and at least know what they're supposed to do, but it's still super, super important that coordination happens, okay? Because QII is way, way more than just putting the insulation in nicely, okay? It's even more complicated on the parts where you have to make sure you have a continuous air barrier and all that other good stuff, okay? So it's a prescriptive measure, all right? It used to be an extra credit. It was purely optional. It was an extra credit, and you could say, yeah, I'm going to do it, or yeah, I'm not going to do it. You could use it to pass if you needed to, or you could completely ignore it. Well, now it's a prescriptive measure. Oh, cool. Looks like there's one coming up. Awesome. Um, and so now it's a prescriptive measure. And what that means is in the performance compliance approach, there's two models, there's two houses. There's the proposed house, which is the house that you want to build, and there's the standard house, the house that you're being compared to. The standard house is essentially the same exact house as the proposed house, but it has the prescriptive measures on it. Okay. Your house has whatever measures you want to put in it. And so it runs a simulation of both of these things, and it compares energy use. All right. Well, when I say something is a prescriptive measure, what that means is it's on the house you're being compared to. So QII is on the house you're being compared to. So your house, the proposed house, is being compared to a house that has QII. So if you say, I don't want to do QII, well, you're being compared to a house that has it. And so you're going to have to do a lot to make up the difference by not having QII. All right, and that's obviously it depends on your climate zone, and the 3C Ren territory is definitely one of the mildest climate zones in the state, so it's not as bad. But if you get over into the valley and you're doing energy consulting all over the state, there are climate zones where QII is really important and it's a huge credit. Okay, so that's a big deal. So you can't just wave it off now. If your builder says I hate QII, I absolutely do not want to do it, then you need to explain to them that it's going to be very, very expensive not to do it, and they may as well learn how to do it because it is kind of it is sort of the what do they say about a house that just meets code? It's the worst house you can legally build. So a house that has QII on it is really how you should install insulation. It shouldn't be thought of as like an above code thing. The requirements for QII actually come from the insulation manufacturer's installation instructions. So the basis of QII is what the manufacturer of the insulation say how their insulation should be installed. All right. To me, that's a minimum standard. So anyways, but QII is a prescriptive standard. Actually, let me put it this way. Passing QII is a prescriptive measure. If you look at the basic requirements for insulation, it actually is the same exact language as QII. The only difference is QII has to be third party verified. All right. So, anyways, interesting kind of relationship there between QII and a house that doesn't need it. Okay, so go to Energy Code ACE. I don't think these are there anymore. Uh, I used to teach a class with Gina Rada called Decoding QII. I think we've got some scheduled. You can see in the chat, 3C Ren has some scheduled. So I don't think this bullet applies anymore. And as you all probably know, CalCerts went away last year. There were two HERS providers in the state, CalCerts and Cheers. And they were kind of neck and neck, in terms of how many raters they had and stuff like that. And then CalCERS decided to close up. It's still a mystery to a lot of people exactly why that happened. But there are theories out there, but it doesn't matter why it happened. The point is that it did happen. So now there's only one HERS provider, Cheers. I heard I've seen things come through the docket that there's a second one getting approved, in the process of getting approved. They're going to start off only for alteration. So I don't think Energy Consultants are going to deal with them too much until they start getting approved for new construction. All right. But anyways, the point is that CalCERS had this really, really wonderful QII handbook. Okay. And full disclosure, I helped write it. That's why it was so wonderful. No, it was a great document, and I wrote the original version, and then it was revised several times after I left CalCERS. But it was a great tool. We wrote it at CalCERS specifically because the reference appendices protocols were so dry and boring, and no pictures and stuff like that. So we really enhanced it. The problem is there's a big, huge question mark on the whether agencies like 3C Ren and the utilities can legally distribute this now that CalCERS is gone. They own the copyrights to it, and so that's still being settled. But there's nothing wrong with people who own a copy sharing it with other people. Okay, so if you don't have a copy of the CalCERS QII handbook, ask around. It was circulated widely. It was a free PDF document. It was circulated widely for years and years. And I know there's people around that have copies of it. Just ask them, just, hey, can I get a copy? And I don't think there's anything wrong with that at all. There's just some questions as to whether it can be distributed with training and stuff like that. Okay. So anyways, get your hand on that. And we're gonna go through it in this class. Okay. So one of the let's see, make sure I didn't miss anything. Okay. So I put together this table a long time ago when I was teaching classes about QII, because it occurred to me that there's a lot of people involved in the QII process. It's not just the builder, it's not just the um, uh, insulation installer and the HERS rater. Okay, almost every trade you can think of, except the electrician. I know you could even argue the electrician is involved in QII because they have to seal around their sheetrock penetrations and stuff like that. There's a lot of people involved in the process, and there's a lot of steps in the process where they get involved. And so I put together this matrix, and this is very, very generic. Um, and what it shows is the different steps of building a house. All right. And this is kind of geared towards production homes, but it could still apply to a new construction or a custom house. You've got pre-design when they're coming up with the preliminary plans and stuff like that. And then you got the more further along design of the house. And you got design review where people start looking at it and reviewing it and making comments. Then you start building the house. You start grading the property. You start framing. You do rough in, then insulation, then drywall, then all the finish work, and then the final inspection by the building department. And again, this is very generic, and you can change these however you want to. But the point is that there's a whole bunch of steps. There's a bunch of stages of construction, and then down the left-hand first column are all the different people that are involved. You've got the energy consultant, you've got the builder and the architect, you've got the HERS rater, the insulation installer, the framer, the drywall installer, and then all the miscellaneous trades, HVAC, everybody. Okay. And then in this huge matrix, wherever you see text, that is where somebody has to get involved at that particular stage of construction. And as you can see, the HERS rater has a lot of stuff to do. The insulation installer has a lot of stuff to do. All right. But look at the energy consultant. They're involved in the first 3 steps. Okay. But this class is for energy consultants, helping to make things flow smoothly during the process. And so what this red line represents is the flow of information. Okay. So as an energy consultant, make sure this flow of information happens. So you're the one who specifies that this house needs QII. Of course, you got to get the approval of the architect and the builder, but you're going to let them know. You're going to say, look, I've specified QII in this process. So you're letting them know. All right. And then you or them need to then let the HERS rater know. Okay. Now, I think QII is on most projects these days, so this isn't that critical. that you let people know. Most people are kind of assume QII is on there unless you've been asked to model it away. All right. Um, but then now the HERS rater knows. Now the HERS rater can get involved and start doing their coordination, and their coordination is very important too. All right. And so they're gonna, if it's a production home, they're gonna go to the hopefully get invited to the trade coordination meetings, what we used to call the value engineering meetings. And they're gonna say, look, you got to move this around here, you got to move this is gonna be a problem, this is gonna be a problem. They work out all the details. Then the HERS rater starts coordinating with the trades. Okay. But as the energy consultant, you need to make sure this flow happens and that everybody is well informed of what's going on. All right. If you don't do that, if you just check the box and not tell anybody, and then they don't realize that QII is required, this is what happens. There's no flow of communication. All right. And then you get to the very end, you're like, oh, shoot, we failed QII. What are we going to do? Or the building inspector comes out and says, hey, how's your QII inspection going? They're like, oh, shoot, we didn't know that. Again, this isn't as common as it used to be. Back when QII was an extra credit, this happened all the time, and it was a nightmare. All right. So, anyways, the point is communication, coordination, logistics. All right. Make sure that happens. All right. Some builder tips. If the project needs QII, evaluate the plans very carefully. Look for unclear parts of the thermal boundary. Make sure that that envelope is a continuous envelope, like a balloon. If you were to fill that house up with water, where's that water going to leak out of? Okay, there should be no leaks in that house. Decide exactly where the thermal boundary will be. Define responsibilities for trades. Who's responsible for what? Who's going to do the air barrier? Who's going to do the blocking? Who's going to do the attic venting? Who's going to seal around fans? Sometimes this is not clear in the contract. And then what happens is you get out in the field and the HERS rater goes, hey, you guys didn't seal around the electrical penetration in the top plate. And the electrician goes, oh, that was their job. And that person over there goes, oh, no, that was their job over there. And they start pointing fingers at different people. Okay. Builders, make sure all this stuff is very clear in your contract. And then contact the HERS rater early. Ask for checklists, ask the HERS rater, talk to the HERS raters. Most experienced HERS raters, this is not their first rodeo, and they can say, oh my gosh, these huge fiberglass tub inserts that slide up against the wall, they're really hard to insulate behind and sheetrock behind. And if you don't, it'll fail the test. Or these giant spa tubs, you have to insulate and have an air barrier behind them, and that's very difficult to do if you don't plan ahead. So HERS raters can help with that kind of stuff. All right. Meet at the project early, walk through together, learn how to use the HERS provider's registry. Okay. All right. So here's the QII handbook. You used to be able to download it from the CalCerts website. There are some discussions going on about revising this and reissuing a new version that is basically the copyright's owned by somebody else. So you're just going to create a new one. So that will be available hopefully not too long. The QII handbook is basically a condensed version of the RA 3.5, which is the actual protocols. All right. If in doubt, if for any reason the QII handbook conflicts with RA 3.5, RA 3.5 takes precedence. Okay. I think we did a pretty good job making sure there were no conflicts between the code and the handbook. Excuse me, but just in case, just know that the code always takes precedence. One of the big things that fail a lot, draft stops, make the ceiling as flat and level as possible, preventing insulation from falling into the voids, prevent airflow from coming out of the house. Okay. So there's a whole section on draft stops. That's an important part of passing QII. Tub and shower enclosures, I just mentioned those fiberglass tub inserts. If they're being pushed up against an exterior wall, somebody has to come out before that happens, insulate that wall, sheetrock that wall, or put an air barrier on that wall, and then that tub can go in. That did not used to be a common practice. Okay. The common practice used to be just shove those things up against the wall and it was uninsulated behind that wall. All right. So know where your thermal boundary is and things like that. All right. So we talk about that. SPF, spray on polyurethane foam is a big deal. Be aware that you are allowed to have some voids in it as long as it meets the thickness to get the R value. It doesn't have to come all the way out to the face of the studs, whereas fiberglass bats do have to come out. You cannot have voids in fiberglass bats. In spray and polyurethane foam, you can. All right. So there's some stuff there. Attic venting is a big deal. QII requires proper attic venting. And so there's baffles and things like that that need to come into play. QII requires special can lights. They have to be IC and AT rated, airtight rated. Okay, be aware of that. Make sure your downstream folks know about that. Skylight shafts, skylight wells have to be insulated, and have to have an air barrier on both sides of them. That's a new requirement. If they insulate with SPF at the roof deck, you don't have to insulate the skylight wells in that case. Okay. This is my least favorite part of QII, is the stupid insulating the door headers, window and door headers. And the reason that I don't like it is because it's a in the grand scheme of things, it's a minor thing in terms of energy use, but it can actually stop a project. Okay. If this is the last thing that the HERS rater is inspecting and he gets out there and they go, oh, you don't have insulated headers, that fails QII. That alone causes QII to fail. All right. So energy consultants, make sure that your customers, your clients, builder, architect, everybody downstream from you knows when insulated headers are required. Okay. They are required if you are not putting rigid insulation on the outside of the house. All right. Right here. If rigid exterior siding is being used, exterior insulations, that is rigid exterior insulation, not siding, insulation. Like if they're doing a 3-coat stucco, if they have, an 1-inch blue board or pink board or white board on the outside, if they're doing rigid insulation sheathing on the outside of the house, that counts as the header insulation. All right. But if they're not doing that, then the header itself has to be insulated. And that can be a real problem. All right. I've talked to several structural engineers, and they tell me that headers do not have to be the same width as the framing, that they just do that for ease of installation. And that if you tell the structural engineer that the header has to be insulated, they will say, okay, fine, I will put in a more narrow header to have room for that insulation. But if you don't tell them that, they're gonna specify a full width header, because those are simply easier to install. They're not always needed for structural reasons to be that wide. It's just easier to install a header that's as wide as the framing. Okay. So anyways, that can be a big deal. So very, very important that energy consultants, because you'll know by running the CF1R whether or not that exterior sheathing insulation is required or not. And if it's not, you gotta say, hey, everybody be aware, you're gonna have to insulate your headers. Okay. And that's all spelled out in the protocols. Unvented attics are becoming more popular, also called encapsulated attics. This is an unvented attic with insulation up at the roof deck. Okay. And they do that for a variety of reasons. It makes the attic much cooler in the summertime. It's a better place to have your ducts. Okay. It can either be spray on foam. I've seen some where they use a loose fill. They hang fabric from the roof trusses and fill it up with a loose fill fiberglass. It looks like an upholstered attic when you go up in there. It's kind of funny looking. Now, it's important to understand that an unvented encapsulated attic is different than what we call a high performance attic. Okay. A high performance attic has insulation on the ceiling. All right. And not at the roof deck. And it's a vented attic. Okay. For a high performance attic, the insulation at the roof deck is not subject to QII because it's not separating conditioned space from unconditioned space. It's in the top of the attic. It's just keeping the heat out of the vented attic. Okay. So that's an important distinction. All right. Just checking the time here. I do need to speed up a little bit. At the very end of the QII handbook, there are some checklists. Okay. There's the ENV 21 checklist and the ENV 22 checklist. These are basically modified versions of these forms. These are the forms that the installer has to go through and say, yes, I did this. Yes, I did this. Yes, I did this. And also with the HERS rater goes through to say, yes, they did this. Yes, they did this. Okay. So we took those forms, we turned them into checklists so that out in the field, you can actually use them. All right. And then there's also a very helpful document for installers, insulation installers. Um, uh, they don't have an easy time reading the CF1R. All right. They're not used to reading a CF1R Perfo 1. That's like a 14 or 15 page document, the CF1R. And if you hand that to an insulation contractor, they're going to go, oh my goodness, what is this thing? So we put together this little guide of basically how to read the CF1R. As an insulation contractor, where do you need to look in this document to find the important stuff? Okay. So that's a useful tool too. Okay. All right. More HERS measures. SPF, spray-on polyurethane foam, non-standard R values. If you look closely in the compliance software, there's going to be a checkbox where you can say use default R value per inch or use a special R value per inch. And if you say use a special R value per inch, that's not a default number, it's going to trigger having the HERS rater have to check for that. Okay. And so they're gonna have to go out and do a special test just to make sure. So be aware of that. If you use a non-standard R value per inch for the spray-on foam, and there's one for open cell, there's one for closed cell or high density, medium density. Just be aware that that will trigger an extra inspection. Okay, and it gets a little tricky in the registry because if for any reason you're not doing QII but you trigger this, it's hard to find the forms to do it. So 99.9% of the time, if you have this SPF, the special SPF non-standard R value, it will be in conjunction with QII, so the forms will be accessible in the registry. All right. Duct location, surface area, and R value. This is kind of an unusual one. This is where you get credit for burying your ducts. Anything that requires verified duct design, all right, falls under this category. This is a tough one. Because it requires a very careful and precise HVAC layout. It requires a duct design. You need to know how long the ducts are, where the ducts are located, the diameter of the ducts. So you have to do a full-blown design, okay, in order to take this credit. But there's kind of a cart before the horse. How can they do a design if they don't know what the energy features are going to be? All right. So you have to do a preliminary Title 24 report, let the designer use that to design the HVAC, and then you can take that information, plug it back into the CF1R and see what kind of credit you get. Okay. So there's some very, very careful coordination that has to handle with that. And I'm a huge proponent of energy consultants learning how to do duct design so that they're the person doing both of those things. And so that coordination is a lot easier if it's the same person. All right, but that's not a simple task. Doing load calcs is a breeze. Anybody can do a load calc. Picking equipment based on those loads is a little more challenging. Designing a duct system is quite a challenge. Okay, but it's not impossible. And gosh darn it, HVAC contractors aren't doing it like they should. So someone needs to step up and do it for them. And I think Energy Consultants is the perfect opportunity for that. All right. Reduced duct surface area is only a credit if the installed duct surface area is less than some magic default number. Okay. Well, what is that magic default number? You have to go to the ACM. Okay. The alternative calculation method manual 2.4.6.4 and 5. And figure out how to calculate that target number. And then if you install a duct system that's really short and compact and has less surface area than that number, you can get a credit for that. Okay. And so that's a possibility. I don't see that taken very often. Verified low leakage ducts in conditioned space. So if you claim ducts inside conditioned space, if they're going to, let's say they're going to drop a soffit in the hallway and run the ducts through that, that's inside conditioned space. It still needs to be duct tested. Okay. And it's a leakage outside test. So a leakage outside test is you're pressurizing the ducts and you're pressurizing the house at the same time. So if the house is pressurized and the ducts are pressurized, the only leakage that can happen is from the ducts to the outside of the house because the house is pressurized to the same pressure as the ducts. So that's a pretty involved test. So verified a verification of low leakage ducts in conditioned space. If you trigger that HERS inspection, make sure that you're aware. Talk to the HERS rater and say, is this going to be even be doable in this house? Okay. The target leakage is only 25 CFM. That's a very small number, regardless of tonnage. All right. It's highly recommended that the HERS rater do a pre-test before the ducts get covered up. What's called a rough test. So they'll go out when the ducts are installed, but maybe not the registers and maybe not the equipment, and they can do a rough test and identify any leakage with a smoke machine, and seal all the leaks before all that duct gets covered up with drywall. Because if they don't pass a test after the ducts are covered up with drywall, it can be really tricky to fix that problem. All right. Oh, and then it can be very different if you guys are doing energy consulting on really, really big houses. Sometimes it can be really hard to pressurize that house with a blower door because they're so huge. All right. The energy consultant may have to borrow or rent a couple of extra blower doors and pressurize it from multiple doors. All right. So big houses can be a real challenge with anything having to do with blower doors. Big houses can be a real challenge. Low leakage air handler units. It's been a while since I checked, but last time I looked, it's been a year or two. There weren't any low leakage air handlers on the list. And if anyone has checked lately and knows whether they're there or not, please drop that in the chat. Anyways, it's a certification for the actual air handler. They test the air handler to make sure it's tight. And if they're going to install one of those, it allows them to do other things. It allows you to actually take credit for leakage less than 5%. All right. But they have to install that test. And then you have to test for that. They have to install that air handler and you have to test for that leakage, whatever it is, below 5%. Return duct design. I mentioned this earlier. This is if you trigger that, if you say on the CF1R that this is what they're going to do, it exempts them from the airflow and the fan watt draw test, but they have to design and install their ducts to these tables. And what these tables say is based on the tonnage of the equipment, you got to have a certain size duct, and they're huge. They're big, big ducts. Okay. So you got to have room to install these ducts. So don't check this box if it looks like the air handler is going to be in a little tiny closet or something like that. Or if it's in an attic, but it's all surrounded by, stuff and there's not a lot of room in the attic, this could be a really hard thing to pass. Refrigerant charge, I mentioned this one too. It can be modeled away. It's a prescriptive measures, okay, in most climate zones. It can be modeled away if necessary. And if you're doing one of those multi-head mini splits, it can be really challenging. So if the building is calling for a multi-head mini split, you probably want to model away this HERS verification. All right. Even though I'm a huge fan of this verification, I think the HVAC industry brought this on themselves by doing a horrible job charging systems. And ever since HERS raters have started verifying these systems, they've done a much better job. The problem is that certain types of equipment are very difficult. Mini splits in particular can be very difficult. And you can only do this test when it's a certain temperature outside. And so coordination can get very, very tricky on this. All right. But I do think if you can pass this test, I definitely think you should do this test. It's an important test. Airflow and fan watt draw, two of my favorite ones, because I'm a huge proponent of good duct design. Proper airflow and fan watt draw helps ensure properly sized ducts. Okay. Target airflow for this is 350 CFM per ton. All right. That is not a good number. If you pass at 350 CFM per ton, I give that a grade of D-, right? You just barely pass. When I design duct systems, I designed to 400 CFM or higher. All right. So I give that a C or a B, higher than that. So 350 is not a good number, but it passes. All right. It's a very low bar. Let me put it that way. It's a very low bar. In some cases, you can model less than 350 CFM per ton. There's some extra things you can do with zonal control where it'll actually allow you to have less than 350. That's not a good system. but again, it's the worst system you're legally allowed to build. All right, if it just barely passes code. So small duct high velocity systems, Unico, SpacePack, those kinds of systems, they have their own targets. They're different because it's a different kind of system. In 2019, the furnace fan life draw changed from 0.58 down to 0.45. So, I mean, it's been a long time since the 2019 code, but in case you think the number is still 0.58, it's not. It dropped to 0.45. And then non-gas air handling units, which is heat pump fan coil units, are still at 0.58. Got a question. Is the CFM per ton not determined by the selected system capacity and the CFM settings? Let me go back a slide. This CFM per ton is determined by whatever they install. Okay. And it's based on the condenser. So if it's a 3-ton condenser, you take 3 times 350, and that's the minimum airflow they have to pass. So it's the installed tonnage is what determines this. The other, let's see, determined by the selected system capacity and CFM settings. Yeah, this is just a minimum. The actual CFM of what is going to happen when they turn the system on is hopefully a result of a good duct design, and that they've designed it to 400 or better. All right. But when the HRSA rater goes out to test it, it has to be at least 350 per ton or it doesn't pass. The actual is going to be based on whatever it was designed to. But the code just says if you have a 3-ton system, it better be moving at least 350 CFM per ton. Okay. I hope that answered your question, Zach. All right. So those verified SEER, EER, if you model anything above minimum, it triggers this HRS verification. So the HRS rater then has to go to the AHRI directory and find the matched equipment. So this is another really important one. If the energy consultant models higher than minimum SEER or EER, okay, it's going to trigger that requirement. So the energy consultant, I suggest the energy consultant, if they have the information, if they know the make and model number of the equipment, and they usually don't actually, they go to the HRI directory and find that. Okay, but if you can't do that early, then make sure somebody knows. Make sure the installer, the HVAC installer, knows that they're going to have to install equipment that's matched, that has an AHRI matched certification. In other words, that you can find that condenser and that coil and air handler in the AHRI directory matched together with an official SEER rating. Okay. So anything over 14 or 11.7 will trigger that. All right. Heat pump heating capacity. This is going to be an even bigger deal. And the reason is that if you undersize a heat pump, it's going to run on the electric strips a lot more, and that's going to use a lot more electricity. So the compliance software will do a simulation and would determine the minimum size equipment, heat pump equipment that won't excessively run on electric strips. Okay. And then the HRS rater has to go out there and check it to make sure that what they installed meets those requirements. Okay. So anytime you model a heat pump, be careful how you specify the capacity of that. Okay. Whether you let the software determine it, or if you know in advance, you can type in a number. I really encourage you to play around with the software and say, what happens if I do this? What happens if I do this? What happens if I do this? And see how it changes your compliance margin. Okay. Whole house fans. This is a prescriptive measure. It does require some special, it may require some special equipment if it's a big whole house fan. A regular flow hood won't do it. So there's some interesting stuff. You can install a whole house fan without taking credit for it. Okay. If you install a whole house fan without taking credit for it, it does not have to be inspected. But if you take an energy credit for that whole house fan, and it'll say right in the CF1R that HRS verification is required for the whole house fan, the HRS rater has to go out there and measure the airflow, and it better pass. Okay. So be careful with that whole house fan. Some of them are easier to test than others. So you definitely want to coordinate with whoever the installer is to make sure that whatever they're installing is the kind of a fan that can be easily tested, and that it be installed in such a way that it is can be easily tested. So installed unit airflow will be tested. Make sure it's installed somewhere that can be tested. Flat ceiling with no obstructions. Okay. I've seen whole house fans where they put the intake in the side of a skylight well. There is absolutely no way to test that. It's not a bad idea because it's pulling air through that skylight well, okay? But you can't test that. You cannot test it if it's only in a 2 foot wide space. There's no way to get the flow hood or any test device over the top of it. It can be very difficult to test that. So make sure it gets installed in a way that can be tested. Also, there are the whole house fan test triggers some requirements for attic ventilation. Okay, very important. Okay, I'm going to kind of run through the rest of these kind of quick because they're very rare. Central fan ventilation cooling systems. This is one I have never personally seen a project that took this credit. If you guys have ever modeled a house with this central fan ventilation cooling credit, it's don't confuse it with CFI ventilation. All right, it's kind of like it's an outdoor, it's a residential economizer. Actually, I do know of a couple of projects now that I think about it. That there, but it's been a while, been a long time. I think this was modeled, those were modeled actually before this was a credit, now that I think about it. All right, but so if you've ever modeled this, do be aware that there are some really intense stuff. Make sure you go look at this RA 3.3.4. Okay. Duct sealing. Oh, this is a very, very common. I think everybody hopefully understands the requirements for duct leakage testing by now. It's been around for a long time. It is by far one of the most important and most cost-effective HERS measures, duct sealing. Mechanical ventilation. This is going to be on every single new construction house is going to have this test. Okay. There are the two different requirements for continuous. If it's just 100% of the time, it's running 24/7, or intermittent if it's on a timer. If it's on a timer, it's much harder to verify. It's much harder to pass. The HERS rate has to figure out how those controls work. They have to make sure it's set correctly and all this other stuff. It can be a lot more complicated if you model the house with intermittent indoor air quality ventilation. All right, so be aware of that. The 2022 calculations are much more complicated, but it all happens by the software. Do be aware that if you model the house with less than 2 air changes per hour for infiltration, it'll trigger blower door testing to make sure that it's at a certain level. And there's another special trigger for IAQ. Be careful when specifying the IAQ fan watts. The software will ask you for wattage of that fan. Make sure that you're using a real number. Make sure you have an equipment specs for a commonly available fan. If you know the actual fan, great. If you don't, pick a fan that's fairly reasonable, and make sure that the installers are aware that it's going to have to meet that requirement. Multifamily mechanical ventilation IQ. Okay, this one can be a big deal. The whole thing is you've got a multifamily dwelling unit. Okay, you got an apartment, let's say, or a condo with people on the side, and the indoor air quality is either supply only or exhaust only. If it's one of those two, that is not balanced ventilation. Balanced ventilation is when you have both supply and return. That is balanced ventilation. If you don't have balanced ventilation, you're either pressurizing the house or depressurizing the house. That can drive air into your neighbors. All right. So if you don't have balanced ventilation, the HERS rater has to do a blower door test on that dwelling unit to make sure it's tight so that air will not go into the adjacent dwelling units. Okay. The bottom line is it's probably cheaper to put in balanced ventilation than it is to do the test. Okay. So if you're talking to your builder and you say, hey, do you plan to put in balanced ventilation? They go, nah, we're just gonna put in an exhaust fan. You need to tell them, okay, every single dwelling unit is going to need a blower door test. And that could be a big deal. All right. And so they may rethink that and go, okay, fine, we'll put in balanced ventilation, which is air pushing in and pulling out at the same time. It does not have to be an ERV, HRV. It can be two separate fans rather than one fan that does both. Okay. This is just more about that. Reduced infiltration. If you model infiltration in a building below 5 air changes per hour, that triggers a blower door. Okay. It is difficult. If a house doesn't pass the blower door test, it depends on how much it doesn't pass by. It could take quite a bit to fix that. All right. The house is leakier than it's supposed to be. Most of that leakage is behind the sheetrock. Okay. But there may be things like there's no backdraft dampers or something like that causing it to fail that they could fix pretty easily. It should be easier to pass with QII because QII ensures a continuous air barrier. Must be verified prior. Okay. Let's see. Parallel piping. This is a credit that requires a special design of the plumbing. Okay. So if you check this box, you definitely want to make sure that the plumbing designer and installer know that they have to they have to design and install the piping in a special way. Okay. Same thing for compact distribution. All right. Plumbing. Demand recirculation. If the builder wants to put in a recirc system, there's only certain kinds of recirc systems that can get credit. So if you model a demand recirculation credit, you're for credit, you're saying they're going to put in a certain kind, and the HERS rate is going to do that. So be very careful if you specify demand recirculation. Drain water heat recovery. This is a little gadget, a little widget that goes on the drain of a shower or a tub, okay, and a shower, and it recovers heat. All right, there's certain situations where you can't install those. Like if a shower's on a slab on grade house, it's difficult, if not impossible, to install one of these. So you need to know when these can be installed and when they can't be installed. So drain water heat recovery device. All right, we are done. That's all, folks. I will let Naomi do her final slides. And if we have any time at the end, I'm happy to open the mics and let people ask questions.
Yeah, thank you so much, Russ, for getting through all that great content.
Perfect timing.
Just a quick reminder about our Code Coach service. 3C Ren does partner up Imbalance to provide free help both over the phone and online if you have any questions about Title 24. And next slide, please. And just a couple of reminder about some upcoming courses that we have. We have the High Performance Buildings Designing for Utility Costs and Carbon Emissions on the 20th, or tomorrow. And as I mentioned, we actually will be covering QII and a little bit, not a huge amount of the course, but it is mentioned in one of the learning objectives and the creating high performance enclosures. And we have some other courses in March. So if you have any other information, please go to 3cren.org and you can see the rest of the courses. Also, we'll be sending a survey to your email in the next several days. This is your last chance to provide us feedback on this training. This is really helpful for us when it comes to scheduling trainings in the future. Please provide feedback in the report if you like this training, would like to see similar things in the future, and we're always developing new training, so feel free to add any more suggestions. That should only take a couple of minutes to complete. And as I mentioned in the beginning of the course, I will be distributing learning units in the next few days. So if you have any questions about receiving those, please reach out to the email on the screen. I'll also put it in the chat, nnewman@countyofsb.org. And with that, I can pass it back to Russ for any last minute questions.
I just put my email address in the chat. If you have any questions that we didn't cover today, feel free to ask me. Let's see, what do you believe are credentials required to be an energy consultant? Oh, good question. Yeah, that's kind of actually, there are none. But what I recommend, yeah, the energy consultant profession is an interesting one. And this is exactly what I tell building departments, that literally anybody can download the software. There's free software. CBEC Res is a free software. Anybody can download a free software and claim to be an energy consultant and charge people for that. Okay. There are no requirements to who can be an energy consultant. So I tell building departments that be very, very aware that literally anybody can do that. Okay. So the problem is that means that some energy reports are probably, frankly, garbage, right? They're just people like learning the software and going, I guess here we go. and they off it goes. If the building department does not do a good job checking it, it goes through. Okay, and that happens. That happens. So that is exactly the reason why CABEC, the California Association of Building Energy Consultants, came up with a voluntary certification program that allows their members to set themselves apart by having this certification. So I tell building departments, if you see an energy report and they have a CEA certification, that's a very good sign that they know what they're doing. It is not an easy test to pass. I help write the questions. It's a tough test, okay? And it requires a certain amount of experience. All right. It requires that you take a professional practice workshop and all that good stuff. So, all that being said, what I recommend for people who are thinking about becoming an energy consultant is you need to be able to read plans. That's probably the most fundamental skill you need to have is read plans. You need to know how to use the software, whether it's the free CBEC Res or if you purchase Energy Pro, you need to know how to use the software. Okay, and then you need to know the code. So Energy Code Ace, in addition to the RENs, have some great, really basic training. If you're thinking about becoming an energy consultant, I highly recommend that you check with CABEC. It's CABEC, cabec.org. That's the California Association of Building Energy Consultants. It's an association for energy consultants. They have a whole bunch of stuff in there. They have a mentorship program where an expert will mentor you to become an energy consultant. And that's because there's a shortage of people coming into that industry. And the people that are currently in that industry realize there's nobody coming along behind them to do this work. And so they're helping people get into the industry. I think right now there's a waiting list to get on the mentorship program, but it is an incredible opportunity to learn how to become energy consultant. Even if you can't get on the mentorship program, CABEC has a lot of resources and training and links and stuff like that to how to become an energy consultant. So yeah, great question. The silver tsunami. What is that? What is the silver tsunami? I don't know what that is. Oh, I know what it is. It's people getting old. Yes. Thank you. I just figured that out right as you answered. Yes, I resemble that remark. Absolutely. Yeah, it's a big deal. And you know where else I heard that it's a huge problem is building departments. Building departments, there's nobody wants to go into that profession. And they're the average building inspector is getting really old and there's no young people coming into that. It's interesting. Yeah, there's definitely a shortage of new people coming in. Thank you for that. Can you please discuss VCHP credit and how it applies to ductless mini splits? Okay. Yes. So VCHP is a special compliance option. All right. So go into the reference appendices and you'll find the detailed specs in there. So what it is, it's a special compliance option. So think of it as a package of energy features to help you get a certain credit. All right. And this all stemmed from the manufacturers of mini split systems saying, the Energy Commission is not really giving us full credit for our equipment. We would like to get full credit for our equipment because it's very efficient. Well, the problem is it's only efficient under certain conditions. And so what the Energy Commission did is say, okay, if you want full credit for your fancy equipment, your variable capacity heat pumps, you have to also make sure all these other things happen. Okay. And so it's a package of features and how it's installed that ensures that the efficiency is being properly distributed to the house. Okay. And so off the top of my head, if I recall there's some requirements. If it's a ducted mini split, the ducts have to be in conditioned space. If it's a ductless mini split, you have to be providing heating and cooling to all habitable rooms. So living room, dining room, bedrooms have to have the mini split heads, things like that. Okay. So go in the reference appendices. That was the same document I showed that table RA 2-1. There's a whole section in there for VCHP as to what those credits are. Energy Code ACE has a class on ADUs. accessory dwelling units. And in that class, we cover the VCHP credit, because the VCHP credit is a, or I should say ADUs, accessory dwelling units, are ideal candidates for taking the VCHP credit. So we talk a lot about it in that. Where is the energy conservation job security when the Green New Deal is being targeted by fossil fuel industry? Oh, George. Yeah, that's a tough question. Well, let me tell you this. I've been in the energy efficiency / HVAC design world since 1988. And at no point in time was there a real deficiency of job security for that. If you get involved with and obviously, broaden your knowledge, broaden your experience. Not only do you want to you don't want to be like just a residential Title 24 energy consultant. You want to do residential and non-residential. You want to do energy and green. You want to do Energy Star. You want to do, you maybe want to branch out to HERS. So broaden your opportunities. You can be an energy consultant and a HERS rater. A lot of people don't realize that. You absolutely can be an energy consultant and a HERS rater. And then, look into green stuff, look into sustainable stuff, get into HVAC design. Okay. There should be at any point in time, there's gonna be a demand for at least one of those things. Okay. There was a time, during the early recession where they weren't building, they just stopped building houses. Okay. So clearly people who specialized in production homes got hit very hard by that. Okay. A couple of the companies I worked for got hit very hard by that. But there will always be, and when the economy is really, really bad, homeowners are looking for ways to save money, right? And one of the big ways to save money is to improve their homes. So when the economy gets worse, the demand for energy efficiency improvements on existing home actually goes up. Okay, so that's it. It's just, yeah, do the research and broaden your knowledge, and should be fine.
All right, it is 11:59. So unless there are any very quick last minute questions, I think we will close the course out now. Thank you so much for everyone to attending, and thank you so much for Russ for hosting a great course today.
Thanks, everyone.
Have a good rest of your day.